Hello friends, welcome to my channel. My name is Hardik Patel and I create videos based on my knowledge around Python, Django and related technologies. In this video we are going to talk about solid principles. So what is solid principles? So solid principles is an acronym of first letter of 5 different principles. As you can see here on this screen, there are 5 principles I have listed here: single responsibility, open closed, Liskov substitution, interface segregation and dependency inversion. So these are the 5 principles we should take care while developing any program using OOPS concepts. Okay, and we are going to see what are those principles, and we are also going to understand through the example. Okay, so let's get started. So first principle is single responsibility. So in this principle, it states that you have to create a class with only one responsibility. So its basic example I can give you, that is user class, which should manage only properties of user. And the second class, user manager class, should manage the users. So this is what follows single responsibility principle while implementation of user management library, right? So let's look at the code example for this. So as you can see here on the left side, there is one user class. Okay, in this user class you can see it manages the properties name and age. So whenever you try to get those information, it will retrieve using this get info and get name, whatever it is, right? So this is one responsibility of managing properties. And second responsibility the same class takes, that is creating the user by given information, right? So this is why this doesn't follow this principle. And to solve that problem, on the right side you can see there are 2 classes we have implemented. One is user, which takes the name and age, which sets those 2 properties, and you can retrieve by these 2 methods. So these are basically manages only properties. Now if you want to create a user, you do not need to use this user class. Instead you will use user manager class. So if you guys know, in most of the web frameworks also we see models and managers are different in all the cases, right? So this is the one of the best example we can see. Now let's talk about the second principle, open closed principle. So what it states that your class should be open for extension but closed for modification. So example, discount class provides discount based on user type. When user is guest or normal user or VIP or VVIP, and according to them we want to give them discount. Okay, so you have created one class where you want to give discount using give discount method, and what you will do, you will get the customer and the price, and you will see if you will have to write if conditions, that if user is this, then give this discount. In this case, whenever you want to add new user type, you have to touch that class, and that is why it violates open closed principle, right? So to follow this principle, you need abstract discount class where you will have give discount method, that is abstract method, and you will have to create separate classes for different type of customers or users. So whenever you have new type of user and you want to give discount, then you just need to add a new class. That's it. So adding a new class, that is part of open for extension, and you are not modifying existing class because this is the new customer, right? And that is why it says that closed for modification. So let's see code example, exactly what I explained. So on the left side, discount class is there is a give me discount method. So there are a lot of if conditions will go on once you add more and more type of customers, right? But in this case, it's a discount class which is base class where you will have to extend them extend that class into two different classes, guest discount and regular discount, and both are implementing give discount method and returns 20% discount for guest and 40% discount for regular. Suppose you want to have VIP discount, then you have to implement VIP discounts. So this basically shows the example. Nothing specific to this functionality. It can be implemented in many ways, but this is just an example to understand what is open closed principle. Okay, so let's go to the next principle, that is Liskov substitution. In Liskov substitution, child class should be able to substitute parent class. So child class is basically subtype of parent class. So whenever you are using those classes, right, behavior should remain the same whether we use the parent or a child class. Example, when you call the methods using child class instance, and you are just checking that if the instance is of base class, and still you are calling some method which are declared in that base class, right? So that base, whatever method you have declared in base class, those should be inherited, or you can say implemented in your child classes, and those should have same pattern whatever base class has, right? So in that case, if that is happening, then Liskov substitution works fine, it doesn't violate. But let's see the code example. You will understand what I am trying to explain. So as you can see here, we have taken example of notification here, and we have declared one send method. You have to implement this method in your child classes. First is email class, second is SMS class. So here you want to send email notification, so you are just giving email address and setting it up, and when you see the send method, it's the same pattern, right? Send, self and message. So you are just sending email, whatever actual logic you will have for email notification, that goes here, right? And same for SMS. Okay, but if you see here, send method has the same signature of this base class method. But if you see the third class, which is push notification, and in that push notification we have changed the signature for our specific purpose, like self, title and message, because in this push notification we want a title as well. In mobile we see, right? So title, and it might be the another option you can place, that is image, right? So you are writing the logic for push notification here, but this signature is different than the original one, which takes only one argument called message, right? Now if you see this function, which is basically using these classes, notify all, and this method takes notifications, and notifications is nothing but list of instances of email, SMS or not push notification classes. So it can contain it's just total list of, or you can say universal list of instances coming from these 2-3 classes. Okay, and whatever message we want to send for all instances, right? Now what I am doing here, it's like iterating through all the notification instances and trying to send message. So in this case, if you'll see, we are just passing message here because it is a common method and which is there in basic class. Okay, so based on this base class, what you are doing is right, but one of your child class, which is push notification, has different signature, and hence if notification instance is of push notification class, then it will raise an exception of not matching arguments. Okay, but how can we solve this and still follow this Liskov substitution principle? So as you can see here, notification class, everything is same, nothing changed, but just you need to mention, or you just need to take care, that is in send method you do not change the signature. You still can call this send method by one argument only, that is message, and as you can see here, I have put the first argument message and the second argument title is equal to blank, or whatever default message you want to set as a title, you can set it. But still you can say this is the signature which is required to call this parents method, and this is how Liskov substitution principle is followed. Okay, so let's go to the next principle, that is interface segregation. So this principle states interfaces should be as specific as possible. And if you want to follow this principle, you have to avoid adding abstract methods which might be irrelevant to few of your subclasses. Example, email notification class. As we talked about this email notification in previous principle, where we are sending notification to emails only. And in that class, if you are trying to implement phone validation method, then it is useless, right? There is no use of that in that particular class, because we are not going to initialize any phone other than that email address. So that is useless. So if you are creating a base class where you will have phone validation and email validation, both methods are there. But when you are extending that base class into email notification or phone notification, then you have to implement both of them, even though one of them is not required. So make your interfaces or abstract classes as specific as possible. Let's look at the code example for this principle. So on the left side, you can see vehicle class, which has two methods which are abstract. So whenever you are trying to inherit this class, you have to implement both of them. So one is go, which is, it says that you are driving on the road, and the second says fly, so you are flying in the sky, right? So as you can see here, the car is extending vehicle class, and it has to implement both of them, even though we know that car can go on the road only, it cannot fly. So what we have done here, as you can see in fly method, we have raised the exception called not implemented error, and with message that cars can't fly. And for the plane, of course, it can go on the road while taking off, and the second is fly, of course it fly. So we can implement both the methods in this class. So that way this works fine, but for car you had to implement this useless, right? But if you want to solve this problem, you can go on this right side of the slide and check. I have created two separate classes, base classes. One is land vehicle and air vehicle. So land vehicle can be extended by car and can implement go method, right? But for the plane, you can extend both the classes and implement both the methods, because plane can go on the road and fly on the sky, and we can use multiple inheritance here. Okay, and let's look at the next principle, that is last one. Okay, so last one is dependency inversion, where high level modules should not be dependent on low level modules. So what does that mean? So when you are trying to create some service or any kind of big project, and you are trying to use some modules which are very specific, that should not happen in this principle. Both should be dependent on abstraction. So example, request client should not be used directly in any other class. So I will explain this in a bit in that code example. So let's go to that example. So on the left side, you can see here I have implemented one class called request client, and which implements get method. So basically this client can hit the get method or post method, anything if you want to implement here, right? But I'm getting the URL as an argument, and I'm just calling request.get, and whatever response comes back, I'm giving back. So this is basic example. Of course, you can go and implement a lot other things inside that method, but just for example, I have simple get method, and I am implementing another class, that is API service, which is again high level module. And in that high level module, what we are doing here, whenever we are trying to instantiate this class, we are passing the request client, so object of this class, right? And as you can see here, we are accepting only request client's object, and we are just setting that object as a property of that class instance. And whenever this get method is called, the same get method is called from this object, right? Request client's object. So this is very simple, correct? And now if you see on the right side, So basically, yeah, so what is the problem if we do this way? This is violating this dependency inversion rule. Why? Because suppose you want to have something different like curl client, so which basically uses the curl library instead of the request library. So you are implementing one more class which supports only curl related calls, and you want to use that class in this API service directly. So how will you do that? You have to change this, and this is very specific to this class. But instead, if you would have created one abstract class, so let's look at the solution so you will understand. On the right side of this example, HTTP client is the base class where we have abstract method called get, and we have used this base class to create request client, right? And we are setting HTTP client. And now, as you can see, similar this is very similar to this. And now in API service class, we are not using directly this request client, but instead we are just accepting or expecting HTTP client only. So suppose you want to now introduce curl client. So what you need to do here, that is, you just need to create another class similar to the request client, extending this base class, and you can use that directly in this API service without changing it. So that is called dependency inversion principle. Okay. So I think that's pretty much all the scenarios, all the principles are covered. So you guys have any question, please let me know in the comment section. Okay. So that's pretty much from this video. If you have liked this video, please hit the like button and share with your IT friends. Please subscribe the channel and hit the bell icon to get the notification of my new upcoming videos. Thank you and see you soon in the next video.